Okay, now we're going to talk about inverse trigonometric functions. Inverse trigonometric functions are not the functions flipped over. What you read when you say inverse trigonometric functions is the angle whose sine is -1, okay? So if you look at your unit circle and you read this is number 6 on the homework, you read arc as the angle whose sine is. So the angle whose sine is -1 is how you would read that. It can be written like this. If it's written like this, you could say the angle whose cosine is -√2/2. Now, the domain and ranges of these are restricted, and I will show that to you a little bit more. The video should show you that. But when we graph it, I'll explain it a little bit more. But the angle whose sine is -1 is -π/2. So -π/2 is the answer to the first one. It's also -90 degrees, depending on whether they ask degrees or radians. Okay? Now number 10, if we read it, the angle whose cosine is -√2/2. Well, normally the domain of the sine is only between π/2 and -π/2, these two quadrants. But the cosine can't be negative in either one of these quadrants. So we have to take the angle that's in this quadrant only for cosine. Sine and tangent, the domain is from π/2 to -π/2. But the cosine, the domain is from 0 to pi. And you'll hear all that in the teaching video. So, -√2/2, well, what's the reference angle that has a cosine of √2/2? Or, just look at your unit circle, what is the √2/2 over here? Well, we know it's 45 degrees in this quadrant, so that makes it 135 degrees, or 3π/4. Okay, so that would be in this quadrant to make it negative. Okay, so basically, if you just read it, the angle whose sine is, the angle whose cosine is, you should be able to get that, because if you remember doing it on your calculator, you found the angle by doing second cosine, and it came up cosine to the -1, and that's how you found the angle. That's how you could actually do this that way as well. Let's try it out. All right, graphing this. Well, first, if we want to, what they're saying is this is the one-to-one function. In other words, once you start repeating it, and you can't, it'll fail the horizontal line test for a function if you keep going. So here they want you to just darken in the part that can be a function. So let's go ahead and draw this. Now, the angle whose cosine is x. So if we start at 0, the angle is now here, and this is just the, the angles, sorry. Yeah, the angles, yeah. So when we're doing this, let's say 1 and -1, where is the cosine 1? Okay, the cosine is 1 at 0. So we would put that. Where is the cosine 0? The cosine is 0 at π/2. So basically it almost looks like a regular curve, only sideways. So you're going to be sketching it in like this. That would be this whole thing. Now, we know that from 0 to pi, if I just darken that in, that is where it passes the straight line test. After that, if I were to draw a straight line, it crosses twice. So this can't be a function, but this can. So in order for this to be a function, its range is only from 0 degrees to pi, or 0 radians to pi radians. So that is this. And that's why your answers to these problems can only be between 0 and pi for cosine. So the answers to these problems can only be from 0 to pi, and the answers to sine can only be from pi over 2 to negative pi over 2, and tangent, same thing. Now, what about when it's composite like this? Well, we treat it just like any other order of operations. What is the sine of pi over 4? So you can rewrite it. Well, the sine of pi over 4 is root of 2 over 2, right? And then we can read this as the angle whose sine is root of 2 over 2, and it comes out to pi over 4. Well, you might say, hey, well, of course, the angle whose sine is the sine of pi over 4, would be pi over 4. However, what if this angle, even though these are both sine, what if this angle did not fall between pi over 2 and negative pi over 2? Then you have to find the corresponding angle that is between that. So you can never put an answer to one of these problems as any angle greater than pi over 2 or greater than negative pi over 2 in the other direction. So the only difference is cosine. Okay. So here we go. Let's do this one. Let's write cosine, and the angle whose sine is negative root of 3 over 2. Well, negative root of 3 over 2 would be over here, right? Nope, this is positive. So negative root of 3 over 2 would either be here or here. Okay? So if we do, what angle has negative root of 3 over 2? It would be a pi, the reference angle would be pi over 3 because it would be a 60-degree angle. And the sine is negative here and here. So this is 3 pi over 3. So this would be 4 pi over 3 would be one of them. And over here, it would be negative pi over 3. So we want the cosine of 4 pi over 3, or negative pi over 3. So it would just be the cosine of 60, which is 1/2. If it was here. All right. That was number 34. Why did we pick this one instead of the other one? Because this one falls in the range of this one. We couldn't use the other answer because the only answers we can use for sine go between pi over 2 and negative pi over 2. I'm sorry if I didn't explain that while I was doing it. But that's why we would pick the positive, because the cosine is positive here. And that's where we would have to pick it out. So negative pi over 3 would be our answer here. So we would not use that one. We would use that one.